Hello and welcome everyone to today's webinar. We're going to give a couple of minutes for everyone who has registered for today's webinar to join us. Today's webinar is related to our Masters in Cybersecurity at the Graduate School of Sciences and Engineering at Koç University. And we're going to be receiving a sample lecture from one of our professors on the topic of an introduction to data privacy and security, which is one of the lectures, which is part of one of the courses of this master's program. As we wait for everyone to join, I want to set some ground rules. First of all, I would like to introduce myself. My name is Melissa Abache. I'm the Director of International Student Recruitment here at Koç University. Today's webinar, we have invited both international and also Turkish participants, so people who are interested in the topic of cybersecurity, data privacy, data security, but also people who are thinking about applying to a program in the future. So in terms of today's webinar, please know that you're all muted. You may raise your hand, but we're not going to use that feature to ask questions. We're going to be using the Q&A feature of the webinar so that you can type your questions. We're going to kindly ask you to type your questions towards the end of the webinar so that we can read them and then answer them accordingly. This webinar is being recorded and we're going to post the video of the webinar on our YouTube channel. You will be able to see it tomorrow. You will get an automatic email with the link to watch the webinar tomorrow. So it's okay if you miss some parts of it because you can watch it again anytime. And also those who were not able to join us today, they will also receive the video recording. We're expecting the webinar to have a total duration of 1.5 hours. It should be a bit less just in case the question and answer part of the webinar extends a bit further than usual. So what we're going to be covering today, I think we have a good number of participants now, is a very brief overview of our university, Koç University, especially for those of you who may be joining us for the first time and have not, a lot of information about our institution. We're going to talk about the Graduate School of Sciences and Engineering and our Masters in Cybersecurity program. That's going to take a maximum of 5 minutes. Then we're going to have a sample lecture of Introduction to Data Privacy and Security. And then we will have 15 to 20 minutes for questions and answers from participants to our professor, our invited professor. So we're very honored today to have Assistant Professor Mehmet Emre Gürsoy. He's from our Department of Computer Engineering at Koç University, and he joined earlier this year. So he's one of our newest faculty members, and we're very lucky to have him at Koç University. He completed his PhD in computer science at Georgia Tech in the United States, and his research interests include data privacy, security, data analytics and mining, adversarial machine learning, Internet of Things, security and privacy in machine learning, and artificial intelligence. I'm reading all of this because I'm not related to computer science at all, so please bear with me. You can find more about him, his teaching activities, research projects, and all of his current activities at his website, which you can see at the bottom of the slide. So to give you a quick overview of Koç University, we are a young university. We celebrated our 25th anniversary 2 years ago now. And since the beginning, we were set out to be a center of excellence that would provide world-class education and create new knowledge for the benefit of society. So from the start, we have been set out to be a research-intensive university that has a global outlook, not just for the benefit of Turkey, but the whole world. And that is reflected in the way that we have structured our colleges and our graduate schools, which are 4 graduate schools. One of them, which is the one I will talk to you about a bit later, is the Graduate School of Sciences and Engineering. This is where we actually have our largest number of PhD students and also master students across 11 different programs. And even having said that, for the Turkish context, we're also a small university. So we provide a very boutique learning experience, you may say, in terms of the student faculty ratio that we offer both for undergraduate and especially for our graduate programs. Then another big part of who we are as a university, there's so many things to say, but what I want to focus on today is the world-class infrastructure in terms of research that we provide to graduate students. Even if you're doing a non-thesis, more industry or professionally oriented master programs like the Masters in Cybersecurity, you still have access to over 223 research laboratories, research centers, and of course, all of the faculty members in not only in computer engineering, but other colleges and other departments in our university. To talk about the Graduate School of Sciences and Engineering, as I said, it's our largest graduate school in terms of the number of students and faculty members. You can see on the slide the master programs and the PhD programs that we offer in terms of the disciplines. The cybersecurity master program is a non-thesis master's program, and I'll explain in the next slide what that means. But you can see, just for information, what are the other areas that we offer. Of course, cybersecurity is very linked or tied to our computer sciences and engineering and computational sciences and engineering programs too. The way that we offer graduate studies at Koch University, especially in engineering and basic sciences, is that we have PhD programs, which are very similar to an American structure of 4 years or 5 years if you join directly from your bachelor's program. We have masters with theses, which are 2 years, and master non-theses, which are completed in 3 semesters, which are approximately 1 calendar year. We also offer a lot of facilities and support for graduate students in terms of, as I said, research facilities, high performance computing cluster, and cloud support. We have an Office of Learning and Teaching that helps you to become a very good teaching assistant in terms of your technique. For example, teaching laboratory sessions or other types of groups. And you can see there all the different support that we provide. For international students, we have a dedicated international community office, which helps with a travel, visa, residence permit, everything else, okay? Now, briefly, why we're here. This is a program that we're all very excited about at Koch University because it's a new program. And the idea was that we would allow, or that we would bring the opportunity for many graduates in the fields of computer science, computer engineering, electrical and electronics engineering, and other engineering fields, the possibility of learning practical and theoretical aspects of cryptology, computer networks, I mean, all of these areas that you see on the list on the slide. And of course, because we see there's a huge potential for employment in nearly every industry, because every industry needs a cybersecurity expert, and every day shows that that's, more true. In terms of the degree requirements, as I said, it's a non-thesis master. So this means that it's comprised of 30 credits, which are 2 required courses, one in computer and network security and one in modern cryptography. And then you have a choice of elective courses that you have to take over 3 semesters. I'm going to show on the next slide the variety of elective courses that are available. And then we have some non-credit courses, which are the seminar courses related to academic writing, ethics, and a final project. Here you can see the some of the elective courses. Of course, this changes according to each semester what's available, but you can see especially those that start with the codes cyber, like CYBR, and comp, which are related to the computer department. There's a lot of very exciting kind of topics that everyone needs to learn about today if you want to work in cyber security or cryptography, data privacy, and all of these different areas. Here's a suggested curriculum of what those 3 terms could look like, where you have the 2 required courses and just some suggested electives. But again, each student can choose the electives that are meeting their specific needs of new knowledge. Finally, today's webinar is to have a sample lecture from one of our professors. If you're interested to know more about the specific application requirements, the admission periods and deadlines, the tuition of the program, and scholarships, what I would like to invite you is to check the Graduate School of Sciences and Engineering website. In the address that you see there, or if you just visit the homepage, you will be able to find the program. You can see all of that information there. We also have webinars recorded earlier this year around May, in which you can find all of this information, and they're available on our YouTube channel. We won't be taking questions today about these topics because we have answered pretty much all of them before, and we won't be able to answer questions today about the eligibility or the chances of admission of an individual participant to the program. So please keep this in mind when you're thinking about which questions to ask. We want to make this time really useful for those of you who want to ask questions to Professor Gursoy about the topics that he will be covering today. Finally, if you are not sure in terms of the career goals that you want to pursue in doing a master's, and you're not sure between a more professionally oriented master's like cybersecurity or something more research focused like our master's or PhD in computer science, please know that we have a very long running cryptography, security and data privacy research group. You can see their website there. It's crypto.ku.edu.tr, and they're also on Twitter. And we're particularly proud of the placements of alumni who have done master's or PhD under the supervision of the faculty members in that group. You can see where they are. There's international alumni and Turkish alumni who have gone on to do, who have gone on to very prestigious programs at master's or PhD level, or also postdoctoral level, or to work in industry, for example, in Canada. Okay, so with that, I hope I have kept it to time, which I think I have. I'm going to kindly ask Professor Gursoy to open his microphone, and I'm going to ask him to share his screen and introduce himself so that we can now come to the sample lecture part of today's webinar. Okay, I'm going to stop share.
Okay, thank you, Melissa. Let me go ahead and share my screen. It says host disabled participant screen sharing. Can you enable screen sharing for me?
Yes, I will. Okay, I think you're co-host now, so you should be able to share your screen now.
Yes, I think it is working now, right?
It is.
Okay, great. All right. So I guess I can go ahead and start the lecture. So good afternoon, everyone, and welcome to this cybersecurity webinar. As Melissa mentioned, I am Assistant Professor Emre Gürsoy, and I will be giving a sample introductory lecture to data privacy and security. This lecture is going to provide an introduction to the data privacy and security course that I teach, which is one of the courses that are available to you if you were enrolled in the Masters in Cybersecurity program at Koç University. And also the lecture is going to give you kind of like an introduction to the research that we do related to these topics. So I am actually a new faculty member at Koç University. I joined in September 2020. So a lot of you, even if you're Koç University students, might not know me or might not have taken classes from me yet. So here's a quick introduction to myself. So my name is Emre Gürsoy. As I said, I'm an assistant professor. And here's my website if you would like to check out some more information about me. I received my PhD in computer science from Georgia Institute of Technology in the United States. Before that, I received my master's in computer science from University of California, Los Angeles, also in the United States. And before that, I was in Turkey. Actually, I received my bachelor's degree in 2013 and my high school degree from Robert College in Istanbul in 2009. I do research in data privacy, cybersecurity, data analytics, data mining, adversarial machine learning, Internet of Things, and security and privacy in artificial intelligence and machine learning. I have several publications in these areas in IEEE ACM journals. I'm recipient of several awards and travel awards, best paper awards and such for the research that I do. And I also hold 3 US patents. 2 of which are, or all of which are actually quite related to the topics of data privacy and data analytics. Okay, so let me start by motivating, so we said data privacy and data security. So I will start by motivating data. And I will do that by first noting that we're living in this kind of a digital age. where all of us either own a smart device or multiple smart devices, or we interact with multiple smart devices and applications pretty much every day. This includes our laptops, our smartphones, our smartwatches, social media apps, so on and so forth. And based on these interactions, actually, these devices and applications we have end up learning a lot of information about us. So for example, when we purchase something online, devices not only know our credit card information, but also our our transaction history, what items we purchased and how much we paid for it. They know our text messages, who we talk to and what we talk about. Based on the emojis that we use, they may deduce information about our happiness, about our mood. They know who we contact. They know what we're interested in, what websites we visit, what we look at. They know if it's a location-based application, they may know our location through GPS. So on and so forth. So in short, all of these devices and applications end up knowing a lot about us. And the situation is even compounded with the growing popularity of social networks, social media, and also Internet of Things devices, such as smart assistants, speech-based assistants, wearables, and such devices. And actually, all of these devices and applications contribute to the generation of large amount of data, which we term as big data. And big data has 5 V's: volume, velocity, variety, veracity, and value. The V that I would like to highlight in particular here is the value part, which is, as the slide says, just having this kind of big data is of no use to us unless we can turn it into value. So a lot of companies are investing into turning big data that they have into value through data-driven decision-making, through the use of artificial intelligence and machine learning nowadays. And there are some examples of how this has impacted our lives in the past decades already. So for example, for a supermarket or an online marketplace that collects market transactions and purchase histories, actually after logging them, they can recommend items to new coming shoppers. So essentially, notifications, let's say if you're shopping on an online marketplace, saying that customers who bought the same item that you have bought are also buying these other items, right? And they can place these items together in a physical location. They can place these items together actually in order to make it easier for you to buy the items that you might be potentially interested in. And how is this done? It is done by looking at the past transaction histories of individuals. So they look at the past transaction logs. They see, for example, the customers who buy bananas also are likely to buy, let's say, milk. And so therefore, they say, okay, let's put, when somebody buys bananas, we can recommend milk, or we can place milk next to the bananas so that people can find it easier. And it is also for the marketplace, it makes it easier for the marketplace to sell these items. A similar idea happens with rewards cards. I mean, based on your transaction history, you can get different kinds of rewards cards, different coupons of items that you're interested in. Another application could be in the medical domain. So nowadays, when you go to a hospital, there are something called electronic health records for patients. So for example, you go to the hospital, you take a test. The results of the tests are given to you, but also they are stored in the hospital database. And this is good, of course, for tracking your personal health. So let's say you had a test a year ago, you had another test 6 months ago, and another test last month. So it is good for, over time, track whether you're getting better and if you have a sickness, is it progressing? Is it getting better or worse? So it is good for you to be receiving this service from that aspect. So that's the primary use. But there's also a secondary use of this kind of data, which is for medical research, actually. Because if you consider somebody who has a certain sickness, let's say COVID-19, which is a popular example nowadays, you're really just one data point in potentially hundreds of thousands of millions of people. And by aggregating the data, aggregating the health records of all of these individuals, we can do research on how the sickness per time in general, not just for you, not just for treating you in particular, but in general, for the general population, how does the sickness affect the population? How does it progress? And that is a secondary use of the electronic health records. Okay, so as we have established, there's pretty much data about you everywhere, and we sometimes give our data voluntarily. Because we want to receive a certain service. We go to the hospital, we take a test. We want the hospital perhaps to take care of the storage, the secure storage of our data. Or we use a marketplace. We want things to be convenient for us. So sometimes we give this data voluntarily, or we want to receive these coupons. So it is okay for us to give, or we might be happy with giving our data in those kinds of situations. But also sometimes the data collection is an implicit process. It is sometimes written in the fine print. When you sign up to a service, you don't actively think that you might be giving your data, but in fact you are. Or in some situations, it is enabled by default, but it can be disabled by the user if the user wants to. And history and experience has shown us actually that once let's say you download an application to your phone and you install it, and the application asks for a certain kind of permission, you give that permission, but you never take it back. So if you enable something by default, actually very few users go and disable it later. That's what surveys and history shows us. So given that there's data about us everywhere, and we're in this kind of situation, is privacy really a lost cause? Should we just give up on privacy and security and accept the fact that our data is going to be everywhere, we're not going to be private? Or should we still go ahead and work on privacy and security? And it turns out that we do have to actually go and work on privacy and security because we need privacy. We need privacy from an ethical perspective, we need privacy from a law perspective, and we need privacy from a business perspective. So from an ethical perspective, let's consider an example from the real world, the physical world. Let's say that you're in your house, and somebody is looking, using a telescope or something to look inside your house. You would be upset with that, right? You might feel uneasy about that situation. You don't want that to happen. So the digital counterparts, or the digital analogy of this is, you're doing something with an application or on your phone, and you don't want somebody watching what you're doing in a physical space or in a digital space. So from an ethical perspective, privacy is kind of like a basic human need that people want their privacy to be respected in general. Okay, privacy is important from a law perspective, and the importance of privacy from the law perspective is increasing in the recent years. For example, the European General Data Protection Regulation, GDPR, is an important development that happened in the last few years. Similarly, the Turkish KVKK, it is in Turkey, it's called the Kişisel Verileri Koruma Kurumu, or the English version of it is the Personal Data Protection Authority. So that is also a recent development that puts some regulations on how data, or why data should be collected, what data can be collected, and how it should be used. And we have to make disclosures about this to individuals. So it is important from a law perspective to comply with these kinds of new laws and regulations. And also from a business perspective, privacy is important because a lot of things, including customer trust, customer loyalty, the brand value of a company, these things actually do rely on privacy. And this is what is shown in this comic on the right, actually. You can ask, do we really need privacy? But if somebody, if your company is hacked and all the user data is exposed to third parties, none of the users trust you anymore. So your reputation is irreversibly destroyed. Your brand value, the customer trust is destroyed. And so those are, of course, bad outcomes for your company. So we need privacy from multiple perspectives. And there have been examples of how things went wrong in the past. So I would just like to give two brief examples. One of them is the AOL search log release scandal. So AOL used to be a search engine similar to Google, what Google is today. Of course, the smaller kind of services just for search. So in 2006, what AOL did is they released an anonymized version of the search engine logs that they collected. And the search engine logs looked something like this. So for example, they said we have a user that comes with a pseudonymous number. So no names, no locations, but just the number 4417749. And they said for this user executed or searched for the following. They searched for a dog that urinates on everything. They typed mature living, 60 single man landscapers in Milburn, Georgia, and the last name Arnold. And actually researchers from the New York Times were able to, given these queries, the anonymized information, researchers were able to find who these queries belong to. And it was actually queries from a lady called Thelma Arnold, who lived in Milburn, Georgia, who was a 62-year-old widow with a dog. So it made perfect sense for this person to be executing these queries. So they went and asked Thelma Arnold, is this really you? And she said yes. So this was, of course, a big scandal at the time, and it led to a class action lawsuit against AOL. Another example is the Netflix scandal, also from the previous decade. So the Netflix prize was a competition for building a movie recommendation system. What Netflix did was they provided customer data, including the username, the movie that the user, or the multiple movies that the user watched, what grade, what score they gave, did they like the movie or not, what score they gave to this movie, and on what date they gave this grade. And security researchers took this data from Netflix. They actually matched this data from public rating information that you can find on IMDb, the Internet Movie Database. And they were able to de-anonymize or identify these anonymous Netflix users to find, because on IMDb, actually, you have the real names and some information like age, location information, IMDb, which is, of course, not available in the Netflix customer data that is released. But after you do the matching, you can find out the identities of the individuals. Also, there were situations that people watched a movie on Netflix and they rated the movie on Netflix, but since their IMDb profile is public, they did not post the ratings on IMDb. They just entered a private rating to Netflix. But after the matching, researchers were able to also find out the private ratings that the users assigned, which included some movies, for example, that revealed individuals' political orientations and sexual orientations. Also a big scandal at the time. So over the past 10 or 15 minutes, I tried to give you sort of like two perspectives. On one hand, on the left, I said data is everywhere. There is great value in collecting this data, in analyzing this data, and deriving insights from data. And data may be given voluntarily or involuntarily to receive services. That's on one hand. On the other hand, I try to convince you that privacy is necessary from several perspectives, including an ethics perspective, a law perspective, and business perspective. And also things can go wrong, and we have seen things of examples of things going wrong when privacy countermeasures are inadequate. So if we put these two things together, we're given this kind of like a dilemma. We need data, or we have data. We want to extract information from it. But at the same time, extracting this information or sharing this data or doing something with this data may lead to some serious concerns or problems. So what can we do? So this brings us to our goal, or the answer, which is that we need methods for privacy preserving collection of data, or privacy preserving analysis of data, or privacy preserving sharing of data. So the course that I teach is actually, or the research that I do is actually revolves around this goal of how can we how can we collect data first privately, how can we extract information from data in a privacy preserving way, and how can we share data with third parties also in a privacy preserving way. Okay. So before going into some of the sample topics that we cover in the course, I would like to highlight some of the different kinds of threats that we consider in different settings. So I said in the previous slide, data collection, data analysis, and data sharing. So I want to highlight a little bit what we mean by each of these situations. So in the data collection setting, we can assume that we are in a client server situation. We have clients such as Alice, Bob, Charlie, and Dave, and we have a certain entity that we call the server or the data collector who would like to learn or collect some information that is stored on client devices. So let's say you have a smartphone. There is some information, or there is actually in a smartphone gigabytes of information about you on the smartphone, and the data collector is interested in collecting some of this information to infer some useful statistics or extract some value. What are the different kinds of threats, or what are the different kinds of risks that occur in this kind of situation? So one threat or risk is that the data collector is honest but curious. So what we mean by honest but curious is that the data collector is going to follow the general protocol that is established between the server and the client. However, the data collector is willing to learn as much as they can learn. So they are not going to try to manipulate something. They're not going to try to hack your phone, but they would like to learn as much as possible about you. So that is an honest but curious kind of situation. Another kind of adversarial attack type that we're interested in is a man-in-the-middle adversary. So a man-in-the-middle is an adversary that sits between the client and the server. So this is kind of like a third party that does not belong. So they, for example, try to look at the communication, observe the communication between the client and the server, and try to infer information from it. And the third kind of privacy threat or risk is malicious clients. So let's say that we're trying to do something collaboratively in a client-server situation that is going to benefit all of the clients, and it's going to benefit the server as well. Some of the clients might have bad intentions, malicious intentions. So they can actively deviate from the protocol or actively try to manipulate or skew the outcome that is to make it a favorable outcome for themselves. Right? So if we are trying to build a collaborative, let's say, machine learning model or a collaborative statistic, maybe the malicious clients want some other outcome to emerge from this. They extract or they inject, for example, some malicious kind of information, malicious kind of statistics to the model in order for the final outcome to be skewed in a way that they want it to be skewed. Okay, so this is one of the settings that we're interested in. Another setting is the data analysis setting. So in this setting, we assume that there is already a location where user data is collected and stored. So this could be, for example, a hospital database or a school database. When you go to the hospital, you take the tests. Those tests are already stored in the hospital's database. So we have Alice's tests, we have Bob's tests, Charlie, Dave, and other users. And there is an analyst, actually, that could be a trusted analyst who would like to pose some queries to this database. They want to access, they want to learn something from the database, and some results are returned to the analyst. So you can think of this as an interactive scenario between the database and the analyst. And the analyst could be anything that goes from a clerk to a doctor to anyone else. Okay, and this kind of, the threats in this kind of situation include an unauthorized entity posing as a legitimate analyst. So for example, I might try to go to a hospital and claim that I'm a doctor and I need access to the database, whereas in fact, I'm not a medical doctor, so I should perhaps not be given access to the database. So in that kind of situation, we have to have proper privacy security measures in place to stop non-doctors access parts of the database that should only be given to doctors. Another kind of threat is an honest but curious analyst. So this is similar to the previous situation. Here, the analyst could be a legitimate analyst, the correct analyst, but maybe the analyst would like to learn things that they do not need to learn. So for example, let's say that I'm a medical doctor and I have certain patients and I need to understand some information about these particular patients, and maybe there is another patient that is not really my patient, but I am honest about their situation. Sorry, I'm curious about their situation. So I can go and query for their situation. They're not really my patient. I should not have access to their data. However, I try to learn information about them. So this is an application of an honest but curious scenario. I should not really see it, but I try to see it. So there should be countermeasures in place to stop me from doing that also. And the third setting I mentioned was the data sharing setting. So in the data sharing setting, we again have a database that we had formulated, such as a hospital database or school database. And we would like to share some information or share directly the data that we have, or share some statistics, some information that we derive from the data. And these statistics or information could be, some quick results, some AI, machine learning models, or it could really be anything. Or it could be a synthetic version or an anonymized version of the data, whatever it is. We would like to share it with a broad community. And the way that this setting differs from the previous setting is that in the previous setting, we had an analyst who's a trusted entity. In this setting, we have a broad community that is untrusted. So here, you do not know, what kind of attacks may occur to the information that you share with the general community. And so threats or risks in this situation could be malicious or honest but curious members of the community. One additional challenge in this kind of situation is that you do not have any control over the auxiliary resources that are available to the broad community. So the AOL search log release and the Netflix situation were examples of this data sharing situation, actually. They made the data, or they shared the data with the general public, but you do not know what the general public is capable of doing. Because they have infinite amount of time, maybe they have much larger computational resources than you do. Or they might have more manpower than you do. So in this kind of situation, they may be aware of other resources that you might not be aware of, that enables the identification of individuals, right? So, in the Netflix example, the Netflix data by itself could preserve privacy, but the Netflix data used together with IMDb data with some smart algorithms can enable the identification of individuals. So you do not have control over how smart these algorithms can get. You do not have control over IMDb and what information is posted on IMDb. So the challenges here are much larger than perhaps you can imagine at first sight. Okay, so from this point onwards, actually, I will very briefly talk about different kinds of topics that we cover in the data privacy and security course. So I will present one slide roughly for each topic, but I would like to note that each of these topics actually take sometimes several lectures or sometimes several weeks. But I am kind of condensing them, each topic I'm condensing to just 1 or 2 slides so that I can give sort of like a brief overview of everything. So the first topic that we cover related to this is authentication and authorization. So what do we mean by authentication and authorization? So let's say that we have a person and this person would like to access a database. Okay, there are two steps before the person can access the database or a resource. First, we need to authenticate the person. And second, we need to check their authorization. So these two steps are actually very different. They are quite, sometimes people confuse these two steps, or they think of the two things as the same thing, which is not true. So that is why we kind of separate them into two. Okay, in the authentication part, what we do is, let's say this person is Alice. So Alice comes and Alice says, hello, I'm Alice, and I would like to access this resource. The authentication step says, prove that you're Alice. So Alice has to say, I am Alice, and here is some proof. Here is a password that proves I'm Alice. Here's a fingerprint that proves I'm Alice. Here's my face. Here's some biometric information that proves I'm Alice. So that the authentication mechanism can really check and verify the identity. Right? And if the verification is complete and the person is really who they say they are, then we go and look at the authorization step. So we check whether this person has the permission, has the rights to access the requested resources. So for example, even if this person is Alice, maybe this person should not be accessing the database, right? So maybe they don't have the permission to access this particular database. Maybe they can access some other database, but not this database. All right, so that is controlled by the authorization part. So in the course, actually, when we cover these topics, for example, under authentication, we cover passwords, attacks to passwords like brute force attacks, dictionary attacks, keyloggers, phishing attacks, shoulder surfing attacks, defenses against these kinds of attacks, like how to choose strong passwords, how to use salts against dictionary attacks. We cover other means of authentication, such as biometric authentication or authentication via devices you have or apps you have on your phone, or key cards or smart tokens. And also we briefly touch on multi-factor authentication, which is using multiple authentication mechanisms together. Under authorization, we cover in particular database, since this is a data privacy and security course, we cover particularly SQL database access control, which is SQL is a popular database software. So we cover SQL database access control, and we look at how we can grant rights and revoke rights from individuals. Because individuals come and go, and maybe if you're a company and you maintain a company database, employees come and go. And as employees come, maybe you have to give them certain rights, and when they go, you have to revoke their rights, meaning you have to take back the rights that you gave. So you have to manage this process carefully, and you cannot do this manually, because as you scale your company to become a larger company, you cannot manually check everything. So you need automated procedures to do these things, which is a topic that we cover. Another topic that we cover is SQL injection. So in order to understand SQL injection, let us actually look at a very simple website architecture. We have a user, and a certain, let's say, HTML web page is displayed to the user. And the user, sends some information, and then the backend of the website talks to a database, again on the backend, and fetches some information from the database, and returns this information to the user. Right, so I mean, you use websites pretty much every day. You enter your username, your password, you enter some search logs, you enter some or search queries, or you enter some other information to a website. Of course, this information goes and something happens on the back end, on the server side, that you do not see. And oftentimes, these things that happen on the back end involve the usage of a database, right? So the important thing to note here is that the information that is being supplied by the user is becoming part of the query or the access to the database. So whatever the user gives is used in asking the database the relevant operations to perform, or the relevant information to return to the user. And so what is a potential problem in this kind of situation? Of course, if the user is supplying legitimate information, then everything is fine. But the problem is that the user can supply malicious inputs. So if the user gives some malicious inputs, the malicious input becomes part of the information that is sent to the database, which may lead to some unexpected or undesired action. And after this unexpected or undesired action happens, an unexpected response is returned from the database. And then this might cause the website to fail. It might cause the website to crash. It might cause the database to lose records, to lose information. It might cause the database some bogus entries, illegitimate entries to be added to the database. We actually show examples of practical examples of how these attacks may work. We give like code and we give the SQL queries of how you can execute and demonstrations of how you can run these kinds of attacks on real databases, on real MySQL databases. And we also talk about the defenses that you can have against these kinds of attacks. All right, another topic that we cover is data anonymization. So data anonymization is a topic that we actually devote roughly 2.5 weeks or so, because it is, at first it is simple, but then it becomes, when you think about all the complexities and the difficulties and the research questions and the problem, it becomes a more difficult problem quite quickly. So there are different kinds of methods for anonymizing data. In order to talk about them, let me first say what we mean by data anonymization. So let's say that we have this original data that is shown on the left here. I hope you can see my cursor. This data has different kinds of, so this is a tabular data, has different columns, and each row corresponds to one individual. So let's say an individual is coming from a certain zip code that they live at a certain age, a certain nationality, and they have some disease. Let's say this is a hospital data set. Now, what we do in anonymization is that given this data set, we want to transform it in a way, we want to change it in a certain way to make it satisfy some anonymization constraints, some anonymization principle, actually. So what we do to it after anonymization is we obtain this data set on the right. So you can see on the data set on the right, some of the digits of the zip code, the least significant digits actually, are removed. So you can see these 2 digits are replaced by stars. Actually, let me see if I can annotate. It's easier. So you can see these 2 digits are replaced by stars in these 4 records. This last digits in these 4 records are also removed. Right, so you can see this record is actually an anonymized version of this record. This one is an anonymized version of this one, so on and so forth, right? So there is this one-to-one mapping between the anonymized records and the original records. But the anonymized versions have some information removed. Okay. Same thing with the age attribute, actually. So in the original data set, we had the actual number of age, just 28, 29, 21. But in the anonymized version of the data set, we have ages that say less than 30. So we removed these precise age values, the precise integers, but we replaced them with a general age value, which is less than 30. Or in the case of here, we replace them by larger than 40. So these are still correct. When we say larger than 40, 50 is indeed larger than 40, 55, 47, 59. All of them are indeed larger than 40. So we're not really lying when we do the anonymization, but we replace specific values by more general values. This is actually called the process of generalization of values. For the nationality attribute, you can see all of the nationality values are replaced by star. right? So here the original nationalities are things like Russian, American, Japanese, and here they are just star, no nationality information is given. So this is actually called the operation of suppression. So we suppress these values, we remove them from the data set during the anonymization process. Okay, so you might be wondering, okay, we do these kinds of operations, but are we just doing them just for the purpose of doing them, just for deleting some information? Or what is the real purpose of doing these operations? Actually, these operations satisfy a property called k-anonymity. So let me actually delete this a little bit. And I can show you here, okay, the notion of k-anonymity. Here, what we do actually after these generalizations and suppressions, these 4 records here are identical to each other in terms of zip, age, and nationality, meaning that if you only consider a person's zip code, age, or nationality, you cannot pinpoint exactly which one of these 4 records the individual corresponds to. Whereas, so this is true for the anonymized data. Whereas if you look at the actual data, the one on the left, as long as you know the age, the zip code, and nationality of the person, you can say, okay, this person is corresponding to this row, and they have a heart disease. It is easy to find that out. But on the anonymized data, we know that this person is actually one of these 4 records, but we don't know exactly which one, because all of the 4 records, they're indistinguishable with respect to zip, age, and nationality. So even if I know they're from the zip code, they're age 28 and Russian, I don't know if they have a heart disease or if they have a flu disease. Actually, both of them occur with probability 2 out of 4 in this situation. Okay, so they called k-anonymity, and since we have 4 records, so we have 4 records in the first subset of the table. Again, 4 records in the second subset. You can see here, these are also indistinguishable. So in this case, since we divided 4 by 4, we actually call it 4 anonymity. 4 anonymity. And this is only with respect to these 3 attributes, the zip, age, and nationality attributes. If we also place constraints on disease, then we arrive at different kinds of privacy notions, such as L diversity and T closeness, actually. But for sake of time, I will not be able to cover those in detail. So this might look, again, easy at first, but there are many difficulties or challenges when you think about it in detail. So just to give you like some insight on these challenges is first, why did we choose age 30 here instead of 35? Or why did we choose 40 here instead of 45, right? So who is giving these decisions? Why suppress the nationality attribute and do this with the age attribute? Why did we not suppress the age attribute, keep nationality? Here we did a one-to-one, in order matching or in order anonymization of the records. We created these groups 4 by 4 in the order that they're presented to us, but that doesn't necessarily have to be true. So who decides which record should be anonymized or put inside the group with which other record? Who makes the decision for that? Right, so if you consider all of these kinds of different dimensions of the problem, then it becomes a challenging problem. In fact, for those of you who are familiar with computer science or come from a computer science background, this is called an NP-hard problem, which means that you cannot find fast solutions, let's say, to this. So there are many aspects, and some of these aspects and some of the practical algorithms people implement, we talk about them in our course. All right. Let me speed up a little bit. So differential privacy is another topic that we cover in the course. So you might have heard of differential privacy or not, but differential privacy, or in particular local differential privacy, is used nowadays if you have an Apple device, if you have a Windows 10 device, or if you're using Google Chrome. Local differential privacy is actively used by these applications or devices to collect data, telemetry data, and statistics from your devices. So if you have an Apple iOS device, you can go to your phone settings, and you can look at the privacy settings, and you can read the disclaimer that Apple has about how they use differential privacy to collect data from your iOS devices. This is a topic that I myself am quite interested in. I do active research on this, and 2 of my patents are actually in this space, in local differential privacy. Okay, the final topic that I would like to talk about is artificial intelligence or machine learning in cybersecurity. As you probably know, AI and machine learning are very popular, and they're penetrating every aspect of our lives nowadays. And naturally, they have applications to cybersecurity as well. They have applications in detecting fraud, in detecting malware, in detecting spam emails, in detecting fake accounts on social media, so on and so forth. So all of these rely on some type of AI or some type of machine learning in today's state-of-the-art solutions. What do these kinds of applications have in common? These cybersecurity problems, fraud, malware, spam, fake accounts. What do they have in common? They have malicious entities in common, right? So we have people who are committing fraud. We have spammers who are sending spam emails. We have people who are programming malware that are malicious, right? So we have malicious actors, malicious actions, and malicious objects, such as malicious accounts, malicious emails, or spam emails. So these malicious entities, actually, when they see a cybersecurity solution, or when they see a defense against fraud, or they see a defense against malware, they don't just stop and say, oh, there's a defense, I'm not going to attack this system anymore. They don't really say that. They try to somehow attack our machine learning-based cybersecurity solutions also. So this becomes kind of like a cat and mouse game. There's an attacking side, and of course there's a defending side, and they become smarter and smarter as time goes on. Now, this has raised interest in creating secure and robust machine learning models that are also taking this malicious entities into account when designing and learning. And there are different kinds of goals in this kind of situation. So privacy of the training data is one important goal, because we train these models for fraud detection, malware detection, spam detection. We train them on private data. So we use legitimate, let's say, banking information, credit information. We use legitimate file information. We use legitimate emails information in order to separate spam email from legitimate email. But of course, emails, people's bank and credit information are very sensitive. So we need to protect the privacy of them when we design machine learning models. Another important aspect is the confidentiality and the integrity of machine learning models. So machine learning models may be intellectual property. Let's say I'm a company, I have some data, I use machine learning experts, I hire them, or I have some collaboration with them, and I create this nice machine learning model. That might be my intellectual property, right? I might not be interested in, or it might be giving me some competitive advantage. I might not want to share the details of what I did with other parties. Yet these models often have to be shipped to customers. Smartphones, for example, or speech recognition, smart assistants, autonomous cars need to come with these machine learning models. So even if we don't want to really share them with third parties, we have to some extent, put them in customer devices. So this might lead to their confidentiality being compromised, or reverse engineering attacks. And finally, the confidentiality and integrity of the test data is important, because similar to how training data might be sensitive, test data might also be sensitive. So when a new patient comes at the hospital, or a new email comes, and we want to detect whether this person is sick or not, or we want to detect whether this new email is spam or not, we have to feed it into our machine learning model. but of course we need to protect its privacy as well, because that is sensitive. And also one other problem here is the test data might be dishonest, as we pointed out. The spam email usually, I mean, a spammer does not want to be detected by a defense mechanism, so they will try to evade being detected. And as the people who are designing these machine learning-based cybersecurity solutions, we have to stop these kinds of evasion attacks. So last, I will just give kind of like a brief demonstration of what I mean by an evasion attack. So let's say that we build a machine learning model that takes an email and tries to figure out if it is spam or not. And what our simple machine learning model does is it looks at the contents of the email. So here, the contents of the email says cheap mortgage now. So our machine learning model takes cheap and it takes the word mortgage and looks at how many spam emails from the past contain these words cheap and mortgage. And for each of these words, it comes up with a score, a weight that signifies, how likely these keywords occur in a spam email. And the scores of the words are computed, and if they're greater than spam threshold, then this whole email is labeled as spam. Now, if you send an email, if a spammer sends an email that says cheap mortgage now, you can see that this email is indeed correctly labeled as spam by this machine learning pipeline. Yet, if we modify the original email and instead we say cheap mortgage now, and then we insert two more words, we say Joy and Oregon, so name of a person and let's say location of the person, then actually the same scores for cheap and mortgage are kept, but also we assign a score to Joy and we assign a score to Oregon as well. So the name Joy and the name Oregon do not, for the purposes of this example, do not occur very frequently in spam emails. So actually they have negative scores. So now if we sum up the scores of all of the words, we have a total score that is below our spam threshold. So actually by adding these two words, we were able to decrease the spam score of our email. And since our total score now is below the threshold, then we can say this email, or the machine learning model says that this email is not spam. So this is an example of how you can add some text to spam emails to evade being detected by spamming a spam machine learning based spam detector. Okay, with that, I will conclude. I think I'm roughly 5 minutes over time, but thank you for your attention. Here, once again, here's my website and my email address. If anybody is interested in getting in touch or would like to see the details of the work that we do on these topics, feel free to visit my website and check it out. Thank you.
Thank you very much, Professor Gursoy. That was really, sorry, I think my green screen is playing something weird right now. Let me turn it off. I think it'd be easier, yeah. Thank you so much. I actually learned quite a lot. I have questions I will ask you later as a parent of a child and how can I protect his privacy for the future. But for now, I would like to start reading some of the questions. So for all of you who have joined us today, that was a lot to take in, especially if you're new to the topic. So please have a minute to think about your questions. I will start with the first question, which is how to quickly deal with data that is suddenly lost, and can the data be returned again?
That's so it depends on what situation you're or what hardware you have. So if it is just deleted from your personal computer, I mean, what kind of it depends on what kind of deletion it is as well. So if you're just you were playing with your, let's say, Windows machine and you accidentally hit delete, you can just Control Z, or you can find the item deleted in your trash box and bring it back. Another situation is that even if certain things are deleted, actually on the machine's hardware, they just on, if you're using an HDD or a solid state drive, they still remain for a certain amount of time inside your hard drive. So it might be able to retrieve data from those sources as well. That is something that is used in digital forensics, for example. So even if you think the data is deleted, it is not always deleted. You have to go to that physical location on that disk to overwrite that location with 0 bits or 1 bits to ensure that it is deleted and it can never be retrieved again. So if you're in this kind of hardware situation, that is, that would be my answer. In a cloud kind of situation, cloud computing situation, it depends, of course, on what the cloud service provider is doing. And I do not really know, for example, a certain company, I cannot say a certain company is handling data deletion using this strategy or that strategy, because I don't know the particular things that the companies are doing. So.
Okay, thank you. There's a question here. What's the difference between red hats and blue hats? I hope that makes sense to you.
I think this is referring to the cybersecurity situation. We have a white hat hacker, black hat situation, but I have not really heard of red hats and blue hats, so I don't want to say anything. I don't want to commit to an answer.
Perhaps if the person who wrote the question can maybe clarify what exactly are they referring to, that might help us to provide an answer. There is a question here, how to use AI security in IoT, in Internet of Things.
AI security in IoT actually is a very sort of new topic. So it depends. So my answer is it depends on what aspect of AI security you are interested in. So for example, we highlighted some different goals of secure machine learning here. So AI security might refer to, for example, in the IoT situation, it might refer to data that is stored in an IoT device, and different IoT devices might be interested in training a collaborative AI model or machine learning model, and you might be interested in keeping each of the individual data secure or private. How to do that is one question. So for that, for example, you can use techniques like distributed machine learning or federated learning is a popular approach. Another situation that occurs in the IoT scenario is, you have, these devices like autonomous vehicles, let's say, that are driving around, and you want to secure the machine learning models or the AI models that are put inside these autonomous vehicles. That is a very different kind of situation than the previous example, because in the second situation, what we have is we have the model that is already built and it is already shipped, but we're interested in keeping it private, the model private, rather than the data private. So my answer is that we have to look at it case by case. What is the privacy situation or the security situation? What are the different kinds of threat models we have? What are we concerned about? And then we find different solutions. But generally speaking, the solutions come from the solutions we have already in centralized situations, let's say. We extend them in order to be applicable to the IoT or a distributed situation.
Okay, thank you. We have another question. Can someone take SQL injection in .NET framework?
Can someone take SQL injection?
Yeah.
Is that the question?
Yeah. If you open the Q&A window, yeah. Just in case I'm reading something wrong, but I think I read it correctly. So it's asking, can someone take?
So I mean, yeah, I saw the question now. I'm not sure what is particular about the .NET framework. Actually, in any situation where you have a query that is posed by, let's say, let me open the slide. Maybe it is a little easier. Okay, I have to go back quite a bit, I think. Okay, in any situation that you have some communication between, the user and the information that is supplied by the user in any way goes to the database, you should be thinking, or you should be worried about the possibility of an SQL injection attack. I'm not sure if it being a .NET framework or another framework, I'm not sure what difference it makes really. I would, regardless of the framework, I would be concerned about SQL injections and still try to proactively defend against them.
Okay. We have a question here, so I'm going to mark that question as answered. Here's a question out of slides topics. Do you think that there can be a trade-off between runtime performance and accuracy of firewall decisions?
Runtime performance and accuracy of firewall, yes, of course. I mean, as you have more complicated or more layered firewalls, actually it is expected that the process it takes to train them and sometimes also to deploy them might take longer. I think, so let us compare a very simple machine learning based firewall to a very complex deep learning based firewall. The one that's based on very simple rules would be very easy to train, or might just have individuals write the rules manually themselves. That is much easier to train. But in a case where we want to have a complex, self-evolving firewall that is based on a very complex neural network, those kinds of neural networks take days to train on, very specialized hardware. So yes, there is a lot of computation requirements there, especially in the training of the firewall. In the testing of the firewall or in actual deployment of the firewall, the computation power might be similar, or it might differ. Again, depends on the firewall, depends on the situation. There is no universal answer, I would say. It is more relevant in the training time, but in general, as you try to create more sophisticated, smarter solutions, it is going to be, of course, more cumbersome, both in terms of the amount of information and data and expertise you need, and also the computational resources you need. But of course, the smarter and sophisticated the models are likely to give higher accuracy in general. So my answer would be yes, I would expect there to be a trade-off.
Thank you for answering. There's a question here. By the way, I'm going now through the questions that are written on the Q&A box. I have seen there's some questions on the chat part, which I will address after we finish on this side. The questions related to admission chances or prerequisites, we're going to leave towards the end to use Professor Boursoy's time more efficiently. So the question here is, how can I protect the company zero-day vulnerability?
I mean, zero-day vulnerabilities are a thing just by itself. The zero-day vulnerabilities, even, very sophisticated companies, state-of-the-art companies that have, special divisions that work on security and privacy, even they are shown to be vulnerable from time to time. So there is no easy way to defend against zero-day vulnerabilities by definition of a zero-day vulnerability. But the best practice is, of course, use defensive coding strategies. Always assess your framework, in terms of, what kind of errors may occur in your framework, what kind of malicious actions that users can take in your system. And this is going to be different from system to system. In an SQL database kind of scenario, as we show here, is different than another scenario that perhaps does not have a database. So you have to self-assess the vulnerabilities and the threats to your system, and then make sure that they are coded. Each particular aspect of your system is coded defensively, meaning you code them by taking into account the different kinds of attacks that may occur, different kind of malicious actions users can take. Employ cybersecurity experts that do penetration testing, for example. Testing is very, very important, regardless of how defensively you code, how well you program, or how well you think you program. There can always be errors. So it is very important to test, and there are actually tools and experts that do the testing. So if possible, employ them, use the tools, use the people, use their expertise. And that is actually the best kind of defense that we have today. But as we know, I mean, globally, new zero-day vulnerabilities, regardless of all of these things happening and done correctly, we have new cybersecurity problems happening every day. So even these steps are not sufficient to ensure full security for software and systems.
It sounds like
that is the best we can do.
Yeah, it's a very dynamic world, I guess. You have to keep learning and relearning everything all the time. There's a question here about the red hats and blue hats that we mentioned before. The person tried to clarify. So it's saying, yeah, white hats are kind of the good type of security. They defend against black hats, which are considered to be the bad guys, etc. One of my professors mentioned blue hats and red hats, but didn't go into any details about them, and I couldn't find info about the topic. I guess it's still a mystery.
Yes, that is, yeah, white hats and black hats, I'm also aware of this this definition, but the blue hats and red hats I'm actually not aware of. So yeah, I cannot answer that question.
Okay. We'll leave it as homework to try to resolve. But we have another question here. What's the most lethal method or the most problematic type of attack to defend against?
That is a very difficult question. I would say in general, any kind of vulnerability and any kind of attack can be lethal. There is a saying in cybersecurity that is, you are as secure as the weakest link in your system. Because when an attacker tries to find some aspect of the system that they can attack, they don't try to attack the strongest part or the most well-defended part. You can think of it as like a medieval war in the 14th, 15th century. If you're trying to defend a castle, the people are not going to attack the part of the castle that is most heavily defended. They're going to attack the castle from the part that it is least defended. So that is true in the digital world and digital cybersecurity as well. You're only as strong as the weakest part of your security. So in terms of how lethal the attacks can be, as long as somebody can, enter your system using some vulnerability, it is possible that they escalate to higher privileges and do more than you might initially think that they would be able to do. You can think, okay, let's just leave this part. This is not really a lethal vulnerability. Let's leave it open. But actually that can turn out to be very lethal, because let's say you have multiple, open ports on your server. 5 out of the 6 ports are well defended. The 6th port, somebody can run a DDoS attack or can try to corrupt the server by running through executing an attack on the 6th port. So I don't think it is good to say, a certain attack is lethal or a certain attack is more powerful than another. Of course, there can be different situations in which that's true, but I would say in general, any vulnerability is an important vulnerability that should be fixed.
Okay, I will mark that as answered. I'm going to check now some of the questions on the chat section of the webinar. We have a question here. What kind of attack which targets the modem of subscribers and changes the configuration? What is that type of attack, I guess, is the question.
I'm not aware of if it has a special name of those kinds of attacks. It has happened to me before. So it is, these kinds of attacks happen, they occur. I'm not sure if they have a particular name, but yeah.
Okay. We have a question here. Is there a perfect defense system out there? And what about the myth that Apple systems are immune to viruses? Also a very big question.
Yeah, there is no, I don't think there is a perfect defense in general. Uh, there was a question about zero-day vulnerabilities. I think that is one key factor in thinking about perfect defenses and seeing that perfect defenses do not exist. Because as long as there are zero-day vulnerabilities, meaning that there are vulnerabilities that people are not aware of yet, but they might be there, but just people have not found out yet. Uh, since we do not know about them yet, there cannot be a perfect defense that defends against those kind of vulnerabilities. This was true in the past also um, with web servers, Apache web servers. There was a vulnerability that people think were there for more than 1 or 2 years, and later it was found out. So, you know, these kinds of, so that's why there is no perfect defense. What was the second part of the question?
What about the myth that Apple systems are immune to viruses?
So Apple makes the decision of not open sourcing much and not giving much away in terms of how they design things, and they like to keep their app stores and things very highly regulated. That's a decision that they make actively, as far as I'm aware. And that is a different kind of decision than some other companies which open source all of the systems they have, or they open their, let's say, stores, application stores, to all developers and all users, and they enable a much more free-flowing platform. But of course, so this more free-flowing kind of situation happens in Android, for example. So that makes Android phones, for example, a lot more vulnerable than Apple phones, because Apple is much more, tightly regulated and tested. So time will tell, which one of these two mindsets is correct. For the time being, from what I see, of course, I am not an employee of Apple, so I cannot say what kind of vulnerabilities or problems may exist in Apple products. But from the outside, when we look at it, we see that Apple products are relatively more secure than than Android, for example. But we don't know what is happening internally there. But there are these two different mindsets, open source everything, and make sure that everybody gets the opportunity to see that if there are any errors, those can be fixed. People will report any errors they see. That kind of mindset is one hand. The other hand is we keep everything closed. The more we disclose, the more people can see, bad guys can figure out mistakes that we made. So we keep everything closed. That's another mindset. Time will tell which one is correct.
Okay. I'm going to read two more sort of field, like topic-based questions, and then we have about 5 minutes in which we can answer some questions that have been voted by participants regarding a PhD program, and some more like admission type questions, or about the course. So another question is, what's the best way to defend against those DOS attacks? Sorry.
Yes, DOS attacks, denial of service attacks, actually, there are several ways to defend against denial of service attacks. So denial of service used to be a problem probably in the early 2000s. The best way to defend against the DOS attack, I wouldn't say that there's a single best way, but one way is to just enlarge the bandwidth of the server that you're using. The second way is use a firewall, of course, that is important. The third way, I mean, use antivirus, use firewalls, scan your ports to see what ports are open on your server. If there's any port that is open that should not be open, close those ports, because all of those ports can be DOS'd. So the general practices here apply. And yeah, even if, so then the next step becomes, using smarter and smarter firewalls, or using specialized software that you can place before the traffic gets to your server. So you can have a sort of like not like a physical wall, but a digital wall that you can place between the outside world and your server, so that wall can eliminate some of the traffic or bad-looking traffic, incoming traffic. And that wall can be designed using an AI machine learning technique also, or some smart programming. Another way is distributing the computation of the computation workload on the server side. Not just have a single server, but have a collection of multiple servers that distribute the workload. So if one of the server gets bottlenecked, the other service can pick up and answer the legitimate users. And this wall, the digital wall you have, can manage the balance of the load among the servers.
Okay. Then we have a question here. The severity of the attack depends on the type of assets attacked. I guess the question.
The severity of the attack is depending on the type of assets attacked. In many situations, I guess from a practical perspective, of course, we care about the security and the privacy of things that we care about, right? So if something is of importance to us, we care about its privacy and security. So in the physical world, if we have money, or if we have, let's say, a very expensive car or a very expensive device, we care about its security. If we have, let's say, a certain product that is not very valuable to us, both in terms of monetary value and in terms of maybe emotional value, then we don't really care about the security of that product. We can leave it any way we like. And we don't care about whether that's stolen or not, right? So, and that is true in the digital world also. I mean, if the data is valuable, or if the system is valuable, then we care about its security. And therefore, it is correct in general that the severity of the attack depends on the type and the value, I would say the value of the asset that is being attacked. But also, I will recall one of the answers that I gave earlier is that you might think that an attack is attacking only a certain aspect of your system. That might not in general be true. They might have access to a certain part and jump from that part, that is getting more access as soon as they find a way inside the castle. They're not going to stop there, and they're just going to conquer the rest of the castle as well. So, it is not good to underestimate the threats of cybersecurity problems.
Great. So I'm going to mark that as answered. I want to now thank you for those of you saying thank you to Professor Gursoy for the lecture, that you have enjoyed it. I'm very glad to hear that was the goal for today. There is a question here, which is more about, for those of you who said, can I prepare a PhD degree in cybersecurity after I finish this cybersecurity program without a thesis, or must be there a thesis? It depends on the country that you want to pursue that PhD degree in. For Turkey, for example, in order to enroll in a PhD degree, you should have completed a master with thesis. However, there are also some applicants or PhD degrees who can enter the PhD degree just with their bachelor's degree. And it's called a direct PhD. It's longer. But it does mean that you have to take some of the master level courses that you would have taken. So it depends. If your goal is a more research focused career, then within Koç University, you have the option of doing the master's in computer science and engineering, and then specializing during that master's degree in cybersecurity. That's another option you have. So I hope that has answered the question. I think some of you voted to also have that answered. There's a question, I think, again, for Professor Gursoy. Let's think about the course that you're teaching within the cybersecurity master's program. Is it focused on theoretical matters or practical things? That's how I'm going to interpret the question.
Yes, so there's a little bit of both. It depends on the course. Some courses by nature are more theory driven. Some courses by nature are more practically driven. So first, it depends on the course. For the course that I personally teach, which is the data privacy and security course, there is a mixture of theory and practice, I would say. The students who are actually taking the course this semester can say that in the homeworks and in the lectures, we do a little bit of theory as well as some practice that is by nature of the topic is most appropriate to our situation. So when we do, for example, AI machine learning security, we look at the theoretical aspects of it. You know, how can we optimize? How can we formulate, for example, optimization problems to find, you know, good attacks or good defenses, or optimal attacks, optimal defenses. You know, that is the theoretical part, and then we say, okay, let's go ahead and try to implement these attacks and defenses and test them on real data so that we have some real experience and we see these things in action. So I would say it is a mixture of theory and practice.
Thank you. And we have a question on the chat part. Is cybersecurity more general than information security? Or are they referring to something fairly similar?
I would say they're referring to similar things. I mean, so data security, cyber security, information security, those things are oftentimes used interchangeably. I would say, you know, there are different aspects of cybersecurity. So, for example, network security is one aspect of cybersecurity. You know, data security is another aspect of it. Cloud computing security is another aspect. You know, mobile application security. These are all different aspects of cybersecurity. You know, sometimes people call information security as equivalent to data security, or sometimes they call it equivalent of cybersecurity. I would say in general, you know, it is more, I would think of it as being similar to cybersecurity rather than just related to data security when you say information security.
Okay, great. I think now the questions we have are more about admissions, and with that, I will answer those and close today's webinar. You would like to, you know, some participants would like to know about how to obtain a scholarship for this program. So we do have 50%, 25% and 50% tuition scholarships for the Masters in Cybersecurity. There isn't a separate application form or specific criteria because scholarships are awarded on academic merit. So the faculty members in the program and the program coordinator are going to look at your whole application in terms of the transcripts from the university degrees that you have completed at bachelor or even at master's level, which courses you have taken, your overall grade point average, the recommendation letters that you receive for this program, your statement of purpose about why you want to join the program and what are your strengths as a candidate and how you fit for the master's program. And of course, any other information that you can provide that would make you stand out within all the applicant pool. So there is no hard rule in terms of this is how you get a scholarship. If you're a very good and outstanding student in terms of your academic performance and potential, you will probably be identified as such by the admissions committee of the program. So I hope that answers the question. Another question is there any prerequisite we should pass to be successful in this program? This was actually a question asked in our admissions webinar. Back then, Professor Alptekin Kupchu, which is also part of the program, answered that. And I remember he mentioned it's very important that you can show through your grades and courses or professional experience or research experience that you have very good knowledge of programming languages, of mathematics as well, because there are some courses that will require a strong kind of foundation in mathematics. I don't know if you would like to add anything else to that, Professor Gursoy. Like what do you think would make a candidate do very well in this master's? Not struggle.
Yes, so yes, so by nature, the courses are, I would say, similar to, so if you're coming from a computer engineering, computer science background, electrical engineering kind of background, I think you would be more, familiar with or data science kind of background, you would be more familiar with the type of stuff that we teach in our courses. But of course, if you're coming from different backgrounds, also you might do well still in the course, and you might. So, for example, people from mathematics backgrounds can do quite well in cryptography, for example, or in theoretical aspects of the courses. People who have more practical implementation experience might do well in the practical aspects of the courses. But this does not mean that you cannot make up for the rest of the parts. And also, as I said, and as Melissa mentioned, there are many courses that you can take that are both cyber coded courses, and also you can take courses from computer engineering, electrical engineering, other kind of courses as well. And so you can, depending on your interests and your background, you can actually position your curriculum, the courses that you take based on that. And I think that would be helpful to see. Just, in general, you can talk to the instructors and look at the course syllabus to see if you have if you meet the prerequisites for that course. And if you do, that's great. If you don't, then you can perhaps ask the instructor to see, what kind of background would be beneficial or what kind of background is expected in the courses.
Yes, so also related to that, as Professor Rousseau was saying, most of our applicants are coming from an academic background in computer science or computer engineering, but we do have other applicants coming from other engineering fields or basic sciences. In those cases, for example, if they show that they have taken courses or certificate courses online, offline, of course, that helps to strengthen your application. That was another question. There was a question here, for example, if Cisco courses, Huawei courses, certificates, do they strengthen the chance? Yes, they do, because it shows that you have a genuine interest in the field. And of course, the more relevant courses you have taken to, again, help you cope with the content of the courses, it's going to be seen as a plus. As Professor Gursoy say, on the program website, you can see the courses, like the required courses and also the elective ones. And you can have a look at what's covered in those courses, and you can see how much of that have you already learned through your bachelor's degree or from different sources that you might have done before. We're not going to answer questions that are very individual here. I do apologize for that, but the reason I put this slide is that you can see, especially for participants who are joining us from outside of Turkey, if you're an international prospective applicant, you can email us to study@ku.edu.tr and we can check your specific question. And we usually answer within 24 hours. If we don't have an answer right now, we'll let you know. As we figure it out, if it's something that we need to check with the course instructors. And you can also see there the Graduate School of Sciences and Engineering website, gssc.ku.edu.tr, and we have a separate website for international applicants with more specific guidance. So with that, I think I'm going to close today's webinar. I know there's maybe more questions. Thank you everyone for joining us today. I know it's the first Monday of 2021. So I do appreciate that you took the time to join us today. If you're already in classes or in the finals or semester break or just coming off from work, so we really thank you for your time today, and of course to Professor Gursoy for giving such an interesting lecture for us today. So with that, we're going to close off. The video recording will be posted later tonight to our YouTube channel, and you will receive an automatic email from Zoom tomorrow with the link so that you can watch it. Okay, so I hope that answers one final question that we had about that. So with that, I would like to say goodbye. Professor Gursoy, if you want to say goodbye too, and then I'll close the webinar today.
Yes, thank you for your attention, and everybody have a great evening.
Thank you very much. Bye-bye.